It's 10:49 in the morning, Pacific time. Somewhere inside a Google data center, a server reads a small config file, a policy update. Routine. It runs every few minutes. This one has a tiny defect. A field that should contain a string is empty. The code tries to read the field. The field is null. The binary crashes. And then, because Google Cloud is global, because every Gmail login, every docs save, every drive file, every cloud API call on the planet touches this one piece of software. Every instance of it, everywhere, in every region, crashes at the exact same time. In 90 seconds, the internet starts to fall apart. This is the story of how one missing null check, deployed 14 days earlier, dormant waiting, took down Gmail, Docs, Drive, Spotify, Discord, and half of Cloudflare in less time than it takes to finish a coffee. I'm going to tell you exactly what happened, and at the end, I'm going to tell you why this bug is almost certainly in your codebase right now, and you don't know it. Let's rewind. 2 weeks, May 29th, 2025. A team at Google merges a new feature into a piece of internal software called Service Control. The feature is small. It adds support for more granular quota checks, a safety improvement. If a customer starts abusing the API, Service Control can now enforce finer limits based on policy metadata. The code is reviewed, the code is tested, the rollout is careful. Region by region, over 2 weeks, every metric is green. Every canary passes, but there's a detail, a quiet detail. The new code path only activates when a quota policy with new metadata fields gets published. And for 14 days, no such policy exists. So the code sits in production, runnings loaded into memory, deployed across every Google region on Earth. And every single time it's called, it takes the same path it always did. The new code, the new branch, the one that would check for null, it never runs, never executes, not once. In 2 weeks, every engineer who looks at the dashboard sees the same thing: healthy, stable, green, ship it. The bomb has been planted. It just hasn't been armed yet. To understand why this is going to be bad, you need to understand what Service Control actually does. Every time you open Gmail, your browser sends a request to Google. Before that request is served, before a single byte of your inbox is fetched, it has to pass through Service Control. Service Control answers 3 questions. 1. Who are you? It checks your identity. 2. Are you allowed to do this? It checks your permissions. 3. Have you exceeded your quota? It checks your rate limits. If Service Control says no, your request dies. If Service Control crashes, your request also dies because there's no fallback by design. You cannot bypass authentication just because the authentication system is down. That would be a security hole, and Google is not going to build a security hole. And here's the part that matters. Service Control isn't a per-service thing. It's not per cluster. It's not per region. It's one system, globally shared, processing roughly 10 million requests per second across all of Google's infrastructure. Both Google Cloud customers and Google's own products like Gmail, Drive, Docs, and Search. So when I say the API gatekeeper, I mean the gatekeeper for the planet. There are backups, there are replicas, there's redundancy at every level, but the code, the binary itself, is the same code everywhere, all at once. That means if the code has a bug that activates under certain conditions, and those conditions show up in the shared policy data, every replica is going to crash the same way at the same moment, which is exactly what's about to happen. June 12th, 2025, 10:45 in the morning, somewhere inside Google, a completely different team. The policy infrastructure team pushes a quota policy update. It's routine. They push them all the time. There's a bug in their policy generator. Nobody knows yet, but the update it produces has blank fields where metadata should be. Empty strings. Nulls. The update hits Spanner, Google's globally distributed database. Spanner replicates the policy to every region. Fast. Worldwide, 10:49 a.m. Pacific Time. The first region reads the new policy. Service control wakes up that dormant code path, the one that's been sleeping for 14 days. Because now, finally, there's a policy with the new metadata shape. The code runs, reaches the metadata field. The field is null. There's no null check. Nobody added one. Nobody caught it in code review. Nobody triggered it in testing. The code path has never run in production until this exact moment. The binary throws a null pointer exception, crashes. The container restarts, loads the policy again, same policy, crashes again, loop. And because Spanner already replicated the bad policy everywhere, every region, every instance of service control on the planet enters the same crash loop. Within seconds, the new feature was designed to make Google more reliable. It just killed Google. If you were watching Google's internal monitoring at that moment, you would see something back-end engineers almost never see. Not a dip, not a curve, a cliff. The API success rate, which had been sitting at 99.99% for months, drops to 0 in under 90 seconds. One graph. Vertical line, straight down. You'd see it in your peripheral vision, and you wouldn't believe it. You'd refresh. You'd check the dashboard connection. You'd check the metric source. You'd think, this can't be real. This has to be a monitoring failure. And then your pager would go off. On Twitter, 15 seconds later, the first reports appear. Gmail down, Drive not loading. Is Google broken? 15 minutes after that, down detector is a red wall. And inside Google, the war room opens. Meanwhile, outside the war room, the cascade, Gmail won't send. You can read your cached inbox offline. Gmail has that. But the moment you hit send, the request touches service control and service control is dead. Google Docs stops saving. Sheets won't open. Meet calls drop mid-conversation. But Google isn't alone, because a huge chunk of the modern internet is built on top of Google Cloud, Spotify, which uses Google Cloud for a significant piece of its backend, goes partial. Paid subscribers get dropouts mid-song. Discord, which handles login through Google for many users, starts throwing authentication errors. Snapchat falters. Shopify backends degrade. And then, in a moment nobody expects, Cloudflare starts reporting problems. Cloudflare, the company whose entire brand is "we keep the internet running," has a product called Workers KV that, under the hood, depends on Google Cloud. Cloudflare goes partially down because Google Cloud is down. Tens of thousands of websites that use Cloudflare's edge services. Websites that don't know they depend on Google, whose engineers have never typed the words cloud, start serving 500 errors. The world learns a lesson that morning. Even the companies that keep the internet up are leaning on someone else. All the way down, its dependencies. All the way down. Inside Google, the response is fast. 10:51 a.m. 2 minutes after the first crash. Alerts fire. The on-call service control engineer is paged. 10:53. The site reliability engineering team is triaging. They can see the crash loop. They can see it's global. They can see it's happening in every region simultaneously, which means it's not network. It's not hardware. It's the binary itself. 10:55. A Google Meet bridge is open. Engineers from service control, from Spanner, from the policy infrastructure team, from networking, from storage. They're all in the room. 10:59, somebody finds the stack trace. A null pointer exception. In the new quota policy handler, the one that just started running. 11 a.m., root cause identified. 10 minutes. That's how long it took to find a bug that was 14 days old in a code path that had never executed in production, triggered by a policy update from a completely different team. 10 minutes, that's fast. That's genuinely impressive SRE work. But it didn't matter, because even though they knew the cause, you can't hot fix a null pointer. Not in a compiled binary. Not at this scale. You'd have to write a patch, compile, test, push it through safety checks, roll it out region by region. That would take hours, maybe a day. And the entire internet was down right now, so somebody in that war room, we don't know who, typed a different command. Google SREs have something they call the red button. A red button is a pre-built kill switch. For every risky feature, you're supposed to build one. A feature flag, a config value, something that, at the flip of one setting, disables the dangerous code path without requiring a redeploy. The idea is when your new feature explodes, you don't need to compile anything. You just flip the flag in seconds. The new quota policy check, the thing that was now crashing the entire internet, had a red button. It wasn't prominently documented. It wasn't heavily drilled. The team that built the feature had said, internally, something to the effect of, "We're confident this is stable. We won't need to use it." Every SRE watching this right now is laughing, because they know exactly how that story ends. At some point between 11 a.m. and 11:30, an engineer in that war room flipped the flag. The bad code path disabled. Service control stopped trying to read the null metadata. The crash loop stopped. Instances came back up. Region by region, the gatekeeper restored itself. Backlogged requests, a mountain of them, queued during the outage, started draining. 11:45, most regions stable. 12:41 p.m. Google officially acknowledges the outage on its status page, 2 hours after it started. Not because they didn't know earlier, but because officially acknowledging requires the customer communication team, and they were also affected because their internal tools run on Google Cloud too. 3:49 p.m. Most services restored for most users. 6:18 p.m. Full resolution declared. 7 hours since the first crash. In the days that followed, Google did something unusual. They published a detailed post-incident review. Publicly. On their status page, with specifics most companies would bury. They described the dormant code path. They described the missing null check. They described the policy infrastructure bug that caused the blank fields. They described the red button and the fact that it had to be used. The SRE community noticed. The transparency was genuinely praised. A lot of hyperscalers would have issued 3 sentences of marketing apology. Google wrote something that engineers could actually learn from. And here's the irony. They didn't fully address, but the community caught it immediately. The feature that caused the outage was designed to make Google Cloud more reliable. Granular quota checks are a safety mechanism. They exist so that one runaway client can't starve everyone else. They exist to protect the system from abuse. So a safety feature, rolled out safely, reviewed carefully, canaried slowly, took down the planet. Because safety features run code too. And code has bugs. And bugs are patient. There's a phrase the post-incident review used. The code path that failed was never exercised during this rollout, due to needing a policy change that would trigger the code. Write that sentence, sit with you for a moment. Never exercised in production. That's the phrase that chills every back-end engineer who reads it. Because you have code like that. I have code like that. Everybody does. Here's what I want you to take away from this. Google's failure was not a failure of intelligence. The engineers who wrote that code are as good as they come. It wasn't a failure of process. The code was reviewed, tested, canaried, rolled out slowly. It was a failure of the thing no code review can catch. Dormant code. Right now in your code base and mine, there are branches of logic that have never run in production. Maybe a new feature flag. Maybe a fallback path. Maybe an error handler for an API response your tests don't cover. Those branches are not safe because they haven't failed. They're unsafe because they haven't run. The first time they run, you're going to find out what's in them. Google found out that morning. The fix isn't stop writing bugs. Nobody can do that. The fix is assume your bugs exist. Build the red button first, before the feature. Feature flag everything new. Exercise every code path on purpose, not by accident. Treat data shape changes as schema changes, even when the type system says they aren't. Because somewhere in your system right now, there is a field that's nullable, with a reader that assumes it isn't, waiting for the day someone upstream sends a blank. That day for Google was June 12, 2025. Your day hasn't come yet. You still have time to add the check. While Google was explaining its null pointer to the world, a quiet feature was being installed on Windows machines across the planet. It was called Recall. Microsoft said it would help you remember anything you'd ever done on your computer. A perfect photographic memory for your desktop, powered by AI. What Microsoft did not mention, until a security researcher opened the file, was where Recall was storing those memories, in plain text. Every screenshot, every password you typed, every private message, every bank form, all of it, sitting in an unencrypted folder. But that is a different story.